Yes, beta. Good evening, everyone. Good evening. Good evening. I hope all of you are enjoying the sessions and getting benefit from it, right? So, in yesterday's session, we completed some terms of concentration, like we did weight by weight, weight by volume, volume by volume, mole fraction, and I think we finished molality as well, right? We finished molality and the relationship also, some of the shortcuts as well. Okay, and strength, I think which we we covered also, strength. Okay, so we are starting with the molarity today, the most important concentration term. Okay, right? So we are starting with molarity. Good evening. Okay, bacha. Let us start then. Okay. So what is molarity, beta? As I said, the most important concentration term is molarity. Normally, if they don't write which term they are discussing, so concentration of a solution means what? Molarity, right? The most important term. Okay, bacha. So what is the molarity? If they are giving molarity of a solution, what that means, bacha? It means number of moles of solute, right? Number of moles of solute divided by volume of solution. Be careful, it is not solvent, it is volume of solution in liters. Right? It is volume of solution in liters. Mohit is saying N by weight, because that is the number of mole of solute divided by weight of solvent in kg was molality. So here be careful, number of mole of solute, and here we have volume of solution. First of all, it is solution, and second thing, it is liter. Okay, right? So this is it. How we show it, beta? We represent it by capital M. Okay, capital M you can say, and in units you will say it is mole per liter. In units, mole per liter. Capital M is for molarity, small m for molality. Okay, right? Let us see a small example here. So please try to answer this one. Here we have a solution. Instead of writing this statement, I am giving in form of diagram, more easy to understand. Imagine here we are having 120 gram urea in this solution. This is 120 gram urea here, imagine, and here I am saying we are having 1500 ml of solution. This is 1500 ml of solution. Can you find the molarity of solution? Yes, beta. Yes, Mohit, Lakshmi, tell me the answer, beta. What is the molarity here? Very easy. You can find the moles of solute, that is urea, and then give me answer. Right? Okay, so what is it? 120 gram urea. So 120 divided by 60. By doing this, what we got? We got the moles of urea. What is urea? If you are confused with it, it's NS2, right? If you find the molar weight of urea, it is 60 gram per mole. 1 mole of urea have weight of 60 gram, right? So 120 by 60, and here it is 1500 ml. If I will make it kg, I will take about here 1000. So from here, what is coming, beta? 2 is coming here. If you solve this thing, 500 cut it down, so 2 here and 3 here. So finally, what is coming? 4 by 3, right? Mole per liter. Yes, you can say 1.33 molar. Okay, molarity means molar, whereas molality means molal. Sometimes you write. Okay. Now reverse way, you can see better. Reverse way, find number of moles of glucose. Find number of moles of glucose in 0.3 molar glucose aqueous solution, you can say, glucose solution, and they are saying with a volume here, volume I'm saying here 400 ml. I am taking how much volume? 400 ml of solution. As I said yesterday, I don't mention the solvent. It is understood it is what? Water. Okay, active solution I am taking. Yes, Niharika gave the right answer. Okay, Navdeep, Shakeen, last question was right. Everyone gave the right answer. Now give me for this one. Reverse way. They have given the molarity. We have the molarity formula. We have its value. It is N by V. Be careful. V in liter. Don't make mistake. V should be liter, right? So molarity, they gave how much? It is 0.3 molar. 0.3 molar. I want to find number of moles of solute, that is glucose. And the volume they gave it here is 400 ml. And here to make this ml into liter, I will take this one. Number of mole of glucose coming how much? 0.3 into how much? 400 divided by 1000. Clear? So very easy to say from here. If you solve this, what is coming? 0.4 is coming. 0.4. 0.4 into 0.3. Yes. So I can say 0.12 moles. So we have 0.12 moles here, right? By chance, if in the question they ask you, so if I say here, imagine number of glucose moles, how many? 0.12 moles. By chance, if they ask number of glucose molecules, so you know very well how to convert mole into molecules, right? The mole concept we covered, that is number of mole into Avogadro number, that is 0.12 Na. Clear? Or by chance if they ask you weight beta, you can give the weight also. If I ask you in the solution, how much is the weight of glucose? How you find this part? Number of mole into molar mass. Number of mole how many? 0.12 mole into molar mass how much? Glucose 180. So you can convert directly from mole to, you can say from mole to weight, or weight, or you can say molecules also, right? Nothing tough. Yes, beta, Amla, Germany, right? So move step by step. Okay? If like you will be trained when you will solve many questions, then you can do everything in a short way. Roughly you can solve all the questions, right? For now you have to move step by step for some time at least. Okay? Done? So you can see from the moles, from the molarity formula, we can find the moles, right? I'm writing once again the formula. The formula was molarity is equals to number of mole by volume. If you take volume in liter, right? So directly I can say number of moles will come how much? Molarity into volume. M into V directly give us what? Moles. So whenever I will use M into V, I will find moles. But be careful. Here V is in liter. Okay? Got the point? Okay, right, bacha, right? So I'm giving one more question on this basis. So please. So here we have this solution again. Here we are having this solution. Here I am saying it is containing 12.044 into 10 to power 22 molecules, right? We are having so many molecules of, I can say, of sugar, you can say, or sucrose, you can say. Okay, I'm taking glucose only to make it more easy. So many molecules of glucose are taken in this, and here I'm saying we are having 3 liter of solution. Total volume of solution is what? 3 liter. So give me a very simple thing again. Tell me the molarity of solution, beta. What is the molarity of solution? In this case, instead of giving the weight, they gave me molecules. So from molecules also I can find easily the number of moles, right? Give me answer fast. What's coming? Yes, beta, how much? So from here if you see, first of all get the moles, right? If from the molecules you want to find the moles, it is 12.044, 10 to the power 22 here, right? Divided by Na, that is 6.022, 10 to the power 23. So from here you can find the moles. Divided by volume in liters, 3 liter, right? Yes, what's coming from here? From here, if you solve this thing, the mole thing, if you solve beta, it is coming 0.2 moles, right? And divided by 3. 0.2 divided by 3, right? So what's coming here? 0. How much? 0.066, right? 0.066. Shanya, 0.066. Be careful about these points also. It is 0.2, I will divide by 3, so 0.06 will come, na? Not 0.6. One of the option definitely contains 0.6 also. But you have to be careful, 0.066. Because 0.2 is coming from here. Divided by 3, definitely it will be less than 0.2, na? That is 0.066. Fine. 1 or 2, 3 students made this mistake. Right? Monica also wrote 0.66. No, 0.066 or 0.067. Okay, fine. I hope we are clear now. Okay, now we will see the relation of molarity with the weight by weight percentage, and you can say weight by volume percentage. Okay, good the point. First, I am giving you a simple question. We will solve it by normal method. Then I will give you a shortcut. Right? If I give a solution here, find molarity, then I will give a shortcut, right? Find molarity of, I will say, find molarity of 12% weight by volume urea solution. Imagine it is weight by volume. They gave me weight by volume percentage of solution, and they're asking us what? They're asking molarity. First use your general method, and then we will see shortcut also for this. The most easiest question, most important question, right? We know this very well. Yesterday I told how to use this given statement. Nothing is given, just this statement is given. How I will use it? I'm giving you a hint. It means 12 gram of solute, 12 gram of urea. I am saying 12 gram of urea present in how much? Present in 100 ml of solution, right? Right now, from this statement, I can clearly write this one. 12 gram urea is present in 100 ml of solution because it is weight by volume. Now I think you can solve the question. Give me answer fast. Make it fast. Okay. Shakini is saying 2.27. We will check. Any other answer, beta? Okay. What we are having here? We want to find molarity. To find molarity, I will use this. What is solute weight? 12 gram of solute divided by molar mass, how much? 60. So from here, from weight of solute, I can get the mole of solute. 12 by 60. Okay. 2 is coming. Lakshmi say 2. Monica, Yamini. All are saying 2 only. Amla also saying 2. The 12 by 60 is what? 12 by 60 is the moles of solute. How much is the volume of solution? That is 100 ml, right? And to make it liter, I will take 1000. Okay? You will see what is coming from here. It is giving me 1 by 5. It's giving 1 by 5 will cut down, coming what? 10 coming, right? So yes, upside is 10 and downside 1 by 5, right? So what is coming here? It's coming 2 molar. It's coming 2 molar, right? Okay. Why some are saying 2.27, 2.26 something, right? Very easy, na? See carefully. 12 by 60, are the moles of urea divided by 100 ml solution. Solution is 100 ml. Okay, so I have the volume of solution, that is 100 ml. 100 ml into 1000 divided by 1000 will go upside, become multiplying, right? To convert ml into liter. So 2 m is coming, right? Yes, Chandana. 2 molar. Okay, bacha. I hope we are clear now. So if you want to go in short, it is also a short method, nothing long, I think. You can easily solve. Okay, no beta, you will not take the volume of solvent, you will take the volume of solution. Okay, and even you can't find the volume of solvent in this because they have not given volume of solute. And be careful, volume of solution is required, don't make mistake. Fine. Okay, now the molarity is equals to 10. Shortcut, if I go 10 into weight by volume percentage divided by molar mass of solute. You see, in very short you can give the answer. Molarity is 10 into weight by volume percentage divided by molar mass of solute. Okay, it is a short formula, you can say. It is exactly same as above, nothing different, but still by chance you forgot about everything but you remember the shortcut, you can give the answer. Okay, like we can solve the above question. We can solve the above question using this technique. Imagine we are finding molarity. How? 10 weight by volume percent, how much given? 12 divided by what is the molar mass of solute? What is the molar mass of a solute? Urea is solute. How much coming here? 60. Very easy. 12 cut down 5, and how much coming here? 2 molar. Yes, everyone, is it right? Okay, on the same basis I am giving one more question. Try to solve it using this formula. Okay, exactly same I am giving. Question is find molarity of, if I am saying 4.9% weight by volume sulfuric acid solution. Okay, we are having a 4.9% weight by volume sulfuric acid solution. Using this, find the molarity. You have the formula very clearly. Solute is sulfuric acid, right? So please. Is it right? Fast. Okay, 0.5. Right. Everyone is writing 0.5 only. Great. Let us check then. 4.9, right? Remember this, 4.9. What's coming, beta? In solution, if I go, molarity is 10 into weight by volume percentage, that is 4.9, right? Divided by the molecular mass of solute. Solute is sulfuric acid, the molar mass is 98. So here I am taking 98, right? So what's coming from here? 49 divided by how much? 98. Yes, you can say 1 by 2 or you can say 0.5 molar. Very easy. I'm giving you simple data. They can change the data in which maybe calculations can be little lengthy. But otherwise the concept is same only. Nothing different, right? Now I'm giving different question. I'm giving weight by weight percentage, right? Let us see then. I'm writing a question here first, then we will see shortcut also. Question is find molarity of You can say find molarity of 10% weight by weight NaOH solution. Find molarity of weight by weight NaOH solution if density of solution, be careful, this time we need density. If density of solution is, imagine 1.2 gram per ml, the density is gram per ml, right? Whatever density they give, we have to use it accordingly. This is our simple question. In this question, the difference is, this time they are not giving weight by weight, they are giving me weight by, in this question they are giving weight by weight, not weight by volume. If I have weight by weight here, so I will use density. Okay, the above statement, this statement is telling us what? It is 10% weight by weight NaOH solution. It means what? It means 10 gram NaOH present in, be careful, in 100 gram solution. This time I am not having the volume of solution, I am having only weight of solution. I am having weight of solution, so we have to convert the weight into volume, because in molarity I need volume, not weight, right? Okay, bacha. So now we have this thing, we already have weight of solute, is okay, but I have weight of solution, I don't need weight of solution, I need volume of solution, right? I need volume of solution to solve my question for molarity. What I will do now, I will take how to find volume beta. It is weight by density, right? It's weight by density. What is weight here? If you see beta, what is weight? Weight is 100 gram and density is how much? 1.2. So 100 divided by 1.2 ml will be the volume of solution. It is our volume solution. Now we can proceed. So from the weight of solution, I am moving to volume of solution using density. Now remaining is nothing tough, beta. It's very easy to solve the next part. Now I can find the molarity. How we find? 10 by 40. Mole of solute. 10 by 40 is what? Mole of solute divided by the volume of solution. How much? Volume of solution is how much, beta? 100. Divided by 1.2, but it is ml. It is ml. To make it liter, I will use 1000. Are we clear here? To make it, it was moles. It is moles. This is volume of solution in ml. I am making it liter using this, right? So if you solve for this, carefully write. I can say here, it's coming 10 by 40 here, right? And here coming 100 divided by 1.2, and here by how much? 1000, right? Make calculations properly. Okay? Take things upside down and properly. Sometimes we do mistake. We know the concept, still we get the wrong answer. Okay? So if we solve this thing, what is coming, bacha? Yes, but if you solve, what is coming from here? You're solving this here, right? 10 is coming. Like cancelling out this thing. What's coming from here? 12 by 4, right? What's coming? 3 molar. Is it right? 3 molar is right, beta. Calculations are okay? Check again. Here we have 1 0 1 0 cancel, 4 is remaining. From here I will solve what is coming. 10 will remain, 10 will make it what? 12. So 12 by 4, right? 3 is coming. Fine. Yes, Germany is saying 3. Okay. Be careful about the calculations. Don't make mistake. Okay? I hope we are clear now. It's 3 molar. Some students are making mistake in calculations, I think. It's 3 molar. Fine. Now we can see, but a shortcut also, like if by chance If you remember the shortcut, it is more easy to solve the question. Look at this. The molarity is 10 into weight by weight percentage divided by molar mass of solute divided by molar mass of solute and density of solution here. This is density of solution. Okay. So what difference is coming in this formula? So what is the difference in this formula from the previous formula, beta? Can you tell me? What is the difference in this formula from the previous one? When weight by volume was given, in the weight by volume there was no need. In the weight by volume there is no need of density. But when they gave me weight by weight, then you see we need density of solution. In this case we need density, right? Okay, Mandeep saying 3, Shweta also saying 3, fine. Now, let us see if we want to solve the same question using this formula. Yes, Shanya, right. So 10 into weight by weight percentage, beta, how much given? By chance 10 is given. The molar mass of solute is how much? 40. Yes. And density given how much? Density given 1.2. Fine. Direct we can get the answer. So what is coming here? Here coming 100. Downside how much? 40 into what is coming here? 1.2. If you solve 120 by 40, it's very easy to get the answer, 3 molar. 10 into weight by weight percentage divided by molar mass of solute into density is there, right? In weight by volume percentage formula, there was no density. Are we clear here? Are we clear? Okay, one more question I am giving on this basis. Yes, everyone. I hope we are clear. Fine. The next one. On same basis, we have one more question. Carefully give the answer. Find molarity. Find molarity of you can say %36 weight by volume glucose solution. These are hypothetical, okay? So density I am writing like whatever I am thinking this way. Find the molarity of 36% weight by volume glucose solution if I am saying density of solution. If I am saying density of solution is 1.2 gram per ml. Okay, like something is given to us. Something is given to us, right? Is beta in the formula, in this formula, density units are definitely is gram per ml. Is beta Shakin? The density will be given in gram per ml. Always they will give gram per ml. Don't worry about that part. Density is gram per ml. Is bacha? Tell me the answer to this question. Don't confuse yourself. See carefully which formula I have to use. Which formula I have to use here. Don't confuse by the given data. Sometimes they gave us some data which is not required. Don't mistake that way. Sometimes they will give you some data which is not required. Whatever is required, you use the data. Remaining will remain as it is. It's fine for us. Fine. So here in this question, be careful. What they gave? They gave us weight by volume. Do I need density here? Do I need density? No, I don't need density in this question. I can find directly the molarity is 10 into weight by volume percentage, that is 36, divided by molar mass of solute, that is glucose 180. I don't need any density. Okay, so don't confuse yourself. So what's coming from here? 3,6 divided by 180. Yes, it is coming 2 molar. It's coming 2 molar. Yes, I don't need any density. Be careful about it. Fine. Good. The next term is I'm taking the next type of question, beta. First, I am explaining how we will, if by chance this question come, how we will solve it, and then I will give you a shortcut, right? The next part is, question is find molarity of, it's an NCERT question, nothing else. Find molarity of, or I will say, imagine I'm asking you find molality. I'm asking molality. Find molality of a 3 molar Na2CO3 solution if density of solution, beta, if density of solution is given as 1.25 gram per ml. Now this question is relating the molarity and molality. If you know the shortcut, you can answer this question very easily. Nothing tough here. I'll give you a shortcut after the conceptual thing. Okay? You should know the shortcut definitely to solve the question in less time, but first of all, concept also very much important, right? So let us understand first what they are doing here. Right? So in the question, if you see, they gave me the molarity. They gave me molarity, right? Whenever in the question they gave you one concentration term and they ask you other term. So look at the first term. What is the definition of first, beta? They gave me molarity. The molarity they gave, first of all, what is the formula? Number of moles divided by volume. It is the molarity formula and the value is given to me 3. It is 3, right? I can write 3 by 1. 3 you can say, or 3 by 1 I can say. Equate the numerator and equate the denominator. So from here I can say I am having 3 moles of solute and solution volume how much? 1 liter. So I can say here we have 3 mole of solute and I am having here 1 liter of solution. Right? So from the molarity formula I can understand this part. They are trying to say 3 mole of solute are present in 1 liter solution. Some students will say, sir, it is also possible, na? 6 by 2. Yes, you can take 6 by 2 also, it's no issue. If a solution is 3 molar, it means it contains 3 mole of solute per liter of solution. That we have to understand. Clear? So I can say I am having 3 mole of solute in 1 liter of solution. Clear? So I am writing this thing here. So I am writing the first part. We are having 3 mole of solute in our solution if I am taking solution 1 liter. That is Na2CO3. Be clear. Because our solute is Na2CO3. And the next thing is, they are saying volume of solution is coming 1 liter. 1 liter you can say, or I can say 1000 ml. 1000 ml, right? Now come to the main thing. The thing is, to find molality, yes, everyone answer me. If I want to find molality, in molality I need weight of solvent, right? I need weight of solvent. But here though I don't have anything like that. So first of all, from the volume of solution, I can find the weight of solution, right? I can find the weight of solution. How? What is weight? Volume into density. Volume is 1000 ml and density is 1.25 gram per ml. So from here it is coming 1250 grams. 1250 gram is the weight of solution. Weight we have, volume we have, density we have, and we have volume, so we can find the weight. Now I can find the weight of solvent. When we will use shortcut, then this will not take so much time. Okay, we will write a shortcut also, don't worry. The weight of solvent is what? Weight of solution. It is weight of solution minus, I will say, weight of what? Solute, right? The weight of solution, I can say clearly, it is 1250 gram. Find weight at 1250 gram. And what is the weight of solute? Come above side a little bit. I am having 3 mole of solute. What is solute? Na2CO3. Can I find the weight of Na2CO3? Yes, better, we can find very easily. Mole into molar weight, that is 106. So you can say from here we are having 318 gram. So 318 gram is the mass of solute because we have 3 mole of solute. So from here I can say, if I will remove 318 gram from here, so I will get the weight of solvent. So what is coming the weight of a solvent? If you remove it, 1250 minus 318, tell me what's coming. 1250 minus 318, 950 minus 18, I hope we are getting 932 gram. It's coming 932 gram, right? Okay, so this is how we get the weight of solvent. Now we come to the main thing. Yes, Shweta, right? I want to find molality. How we find? Mole of solute divided by weight of solvent. In which term, beta? In kg. So mole how many? 3 mole. And how much is the weight of solvent, beta? 932. Make it kg by taking 1000. So from here it is coming 3000 divided by 932, right? So 3000 divided by 932 is coming. So if you solve this thing, what is coming? Tell me how much coming? 3000 divided by 932. Yes, everyone, give me the answer. Then we'll write a shortcut also so that you can save your time without writing so many things. Concept remains same. The shortcut just tell you the last point directly. Tell me what's coming. If I divide 3000 divided by 932, definitely 3 point something will come, right? What's coming? 3.33 or 23? Okay, whatever is coming, 3.33, 3.23, whatever is coming, I'm writing 3.23. As you are saying 3.23, I'm writing 3.21, 3.23, fine? Okay, right. Fine, bacha. Now I will write the shortcut, okay? We have seen what is the concept behind it. From the first line, we took 3 mole solute in 1 liter solution. From volume, I got the weight of solution. I can get the weight of solvent. If I have the weight of solvent, I can get the molality very easily by the formula, right? Now, we can write the shortcut also, fine? Okay. So what's coming? The formula is molality is what? 1000 into molarity divided by 1000 into density of solution. This is the density of solution minus it is molarity of solution into molar mass of solute. This is a short formula. You can save some of your time using the shortcut directly, right? I'm saying once again, this is molality. Small m is representing here molality, and the capital M is showing the molarity. So can we solve the above question using this shortcut? Right? What is it? This is molar mass of solute. What is it here? Density of solution, very easy. You can see clearly, still I'm writing to avoid confusion. It is density of solution. Fine. Okay, we can try to solve the above question using this. I want to find molality. How? 1000 into the molarity was given 3. In the previous question, molarity was 3. 1000 into 3 divided by what? 1000. Density was 1.25, right? Minus the molarity. But what is the molarity? The molarity was 3. Now, what is the molar mass of solute? It was Na2CO3. Na2CO3 have mass of 106, the molar mass, right? So 106 coming here, right? So if you solve this thing, 3000 coming above side, 3000 coming above side divided by 1250 minus 318, it is coming 932, and that was giving us what? It was giving us 3.23 almost, right? Clear? So same thing you can solve in very less time if you know the shortcut, right? But definitely for that you have to remember it. Are we clear about it? So we related the molarity with weight by weight percent, with weight by volume percent, with the molality. So this way many applications are possible. We can connect two terms this way. Okay. Now I am coming to next type of problems on the molarity basis. Okay. The first one is dilution. The next thing in molarity only. So I am writing molarity change on dilution, or I can say, okay, molarity change on dilution. So how molarity will change if we do dilution? I hope we are clear. Okay, beta. So molarity change on dilution. So here we have first, what is dilution? Dilution means addition of water in solution. We are having a solution, and if you add water, so here we have addition of water in solution, or just I can say addition of water. Okay, you have already a solution. In that solution I am adding just extra water. Okay, I am not adding extra solute. I am just adding extra water in that. Right, bache? Okay, let us see, bache. Let us see the concept first of all. What we have here, in this case, imagine we have a solution. Try to understand. Okay, we'll message you later on. First of all, focus beta on the concept. So we have a solution here, right? In this solution, imagine I am having 5 particles of solute. Can you see here? It is not possible to directly show you particles, but I am showing here. In a solution, I am showing you here some water is there, and in that I am showing you some solute particles. In this solution, imagine I am adding extra amount of water. In this solution, I am adding extra amount of water. You will see, bacha, volume of solution is increased, but now also the solute particles are same, na? See carefully. If I add extra amount of water in the solution, the number of solute particles will remain what? Same. Solute particles will not change. Here I have 5 particles, here also 5 particles. Particles will not change, but just extra water is increasing the volume of solution. So imagine before dilution, this process I am calling dilution, right? This is dilution. This is dilution, right? This is dilution. Fine. You see, bacha, here. In this case, the molarity, imagine, is M1, and the initial volume was V1. Imagine before adding water in initial solution, molarity is M1 and volume is how much? V1. The next case is when you add here extra water, finally I am saying imagine molarity is M2 and the volume become what? V2. Okay? Right? So M1 initial molarity, V1 initial volume, and finally after dilution molarity become M2 and volume is what? V2. But the one thing is very clear, the number of solute particles here and number of solute particles here will be same, because after adding extra water solute particles are not changing, right? So if you see carefully, number of solute particles, or I will say number of moles of solute here and number of moles of solute here are what? Same. Number of moles of solute, number of moles of solute remains same. How we find the number of moles solute? Molality into volume, M1 V1. And here also beta, how we find the number of moles solute? M2 V2. So I can say if moles will remain same, so I can write M1 V1 equals to M2 V2. So multiplication of molarity and volume will remain same, even if you do dilution. So if you want to solve the question of dilution, just equate M1 V1 equals to M2 V2. Fine, bacha. What's the point, right? Is it clear? Yes, bacha. So we can say M1 V1 equals to M2 V2 for the dilution question. So very easy question we can see now. One or two small questions we will see for this. Okay. Okay, fine. So M1 V1 equals to M2 V2. Before dilution, after dilution. Out of these four things, 1, 2, 3, 4, they can give you 3 and they will ask you one of the things, right? So very easy topic. We can see, bacha, one question. Imagine here, I'm writing a solution. I prefer to give question in form of diagrams, right? So understand the same thing. So what we have, imagine this is a 0.2 molar NaCl solution and volume I'm saying here 300 ml. Now we are adding water here, we are doing dilution, So imagine because of addition of extra water, you see the total volume is increased now. Now the total volume of solution become 500 ml, right? So in the final solution, what is the molarity? After dilution, the volume become what? After dilution, volume become what? Okay, tell me. Same thing, beta, same thing. The number of mole of solute will remain same, na? It will not change, right? Apply the M1 V1 equals to M2 V2. Give me answer. Yes, beta. Just apply M1 V1 equals to M2 V2. Right? So what is here? M1 V1 equals to M2 V2, and in the question they're asking you what? They're asking you M2. What's M1 beta? M1 is 0.2 and V1 is how much? 300 ml. M2 is how much? M2 is, we have to find M2, and V2 they are saying how much? 500 ml, right? So M2, if you solve from here, M2 is coming how much? 0.2 into 300 divided by 500, right? So if you solve this part, what's coming, beta? What's coming? Tell me. 0.12. Very good. 0.12 mole. Great. Very good. Fine. Okay. One more same type of question, bacha. Question is, find how much water we will add. Find how much water we will add in 300 ml of 0.4 molar HCl solution to make it 0.1 molar HCl solution, right? We have to change its molarity. From where to where, beta? From where to where? From 0.4 molar to 0.1 molar, right? This time, instead of diagram, I gave the direct question. It is 0.4 molar, and here how much? 0.1 molar. Here, the volume is 300 ml, and they're asking something. So be careful, give me the right answer. Carefully give the right answer, don't make mistake. Fine. Shweta saying 1200, Karthik saying 1200, Mandeep saying 1200. Carefully give the answer. I know most of you will make mistake here. Very easy question, but most of students will make mistake. Yamini give the right answer. Shweta, Karthik, Mandeep, be careful. In the question, what they're asking? Beta? Are they asking you V2 or they are asking you the volume of water added? Carefully give me the right answer. What they're asking in the question? Are they asking the volume of solution finally, or they are asking the how much volume of water added? Okay, you are very much right about finding V2. V2 is okay. You are applying here M1 V1 equals to M2 V2. It's okay. It's fine. M1 you are saying, sir, M1 is a 0.4 molar. Volume is how much? 300 ml. And M2 is 0.1. I can find V2. V2 is very much clear. How much coming? 1200 ml. But in the question, what they're asking? The question is, find how much water will be added. Find how much water we have to add, or water will be added. So water, we are adding how much, beta? Water we are adding what? V2 minus V1. Final is 1200 ml, initial was 300 ml. So we added 900 ml water. So in this type of small questions, don't make mistake. Okay, I hope we are clear what I am trying to say in this question. Okay, right? Okay, the next type I am taking here. The next type is, okay, one more thing. One more note you can write here, small note. We have seen already on dilution definitely concentration, or I will say molarity, will decrease, right? Every concentration term will decrease. Here we are discussing about the molarity, so I'm saying molarity will decrease as we do dilution, right? So if I talk about the M1 and M2, M1 I am saying before dilution, M1 I am saying before dilution, and M2 I am saying after dilution. So it is very much clear that M1 will always be more than M2. On dilution, molarity will always decrease. Okay? Sometimes they will not give you the exact data, so you have to just interpret whatever option is less than what? Initial molarity can be your answer. Okay? Definitely, if you do dilution, molarity can never increase. Molarity will decrease if you do dilution, right? And some student is asking, sir, why we are taking volume in ml only? Why we are not making liter? Okay, very common question among the students. Be careful. Here also we have volume. Here also we have volume. If it is ml, it is also ml. If it is liter, it is also liter. So if both sides I am having volume, then there is no need to convert it. If only I am talking about molarity, they are saying find the molarity, we have this amount of solute, this much volume of solution, then I will take volume of solution in liter. But in case of mixing questions and in case of molarity question, like in this type of question, definitely we have to take volume ml or liter, no issue. You can keep ml also because it will cancel out. If you divide here by 1000, you divide here by 1000. So it will remain as it is. It will not make any difference if you convert it or not. Okay, bacha? I hope we are clear. Fine, bacha. The next thing. Okay, the next thing I'm taking now. Question is now molarity will be affected. Molarity change, I am saying molarity change on mixing. Remember, I am writing this for same type of solutions. I am mixing here same type of solutions. I am not mixing here different type. Be careful. I am writing very clearly. On mixing same type of solution. Okay? This you can apply only when you are mixing same type of solution. What I mean by this? Imagine I have a solution here. It's a NaCl solution. Molarity M1 and volume V1. It's a NaCl solution. Here, this is also with a solution. Imagine molarity M2 and here volume is V2. It is also a NaCl solution, right? If you mix both of these, then total volume will become what? I'm calling volume is V3, or V3 is what? V1 plus V2 sometime. If you just add both the solutions, if you add extra water also, then it can be V1 plus V2 plus V water, right? If you just adding, then it is V1 plus V2, right? So instead of writing just V1 plus V2, I am writing V3. So I am writing it M3 and V3 after adding, right? So if I am taking, it is also a NaCl solution. I am mixing here same type of solutions. NaCl solution mixing with NaCl solution, it will remain NaCl solution, right? I am not mixing two different solute solutions, right? Imagine here I am saying I am showing you some particles. Look at this. Here I am showing you 2 particles of solute. Here I am showing you 3 particles of solute. After mixing, definitely total particles of solute will become 5. Here I am saying solute moles how much? N1. Here it is N2 and here it is how much? N3. So I can say N1 plus N2 is equals to N3, na? I can add moles here. Mole of solute here plus mole of solute here equals to here. So I can apply the M1 V1 plus M2 V2 is equals to what? M3 V3, right? So you can apply this formula when you are mixing same type of solutions. Imagine I am mixing here NaCl solution with here you can say NaOH solution or KCl solution or sugar solution. I can't apply this formula. I can apply this formula only when I am mixing same type of solutions. Many students make mistake here, so I am repeating it again, right? Okay, so please tell me the answer for this question. Okay, look at this. Very simple question again. We are having here 0.1 molar NaCl solution. I am saying here its volume is how much? 300 ml, and I am mixing it with the 0.3 molar NaCl solution, and here I am saying the volume is 700 ml. So question is find molarity of final solution, right? Find molarity of final solution. Make it fast. Yes, better. Make it fast. I'm mixing same type of solutions. You can solve it easily by the formula we used here. M1V1 plus M2V2 equals to MC3, right? Yes, better. Fast, fast. What's coming? You can see very clearly. This is giving us, we are applying M1V1. But what is M1? M1V1 plus M2V2 equals to M3V3. But V3 is what here? V1 plus V2 only. V1 plus V2 how much? 1000. If I am taking here ml, so here also what? ml I will take, right? Okay, fine. So from here, how much coming, beta? 30 coming from here, right? What is coming from here if you solve it? 2110, right? And M3 here and 1000. So M3 if you solve, what's coming? 240 divided by 1000, right? So what's coming from here? It's coming 0.24 molar. It's coming 0.24 molar, right? Yes, Yamini gave right answer. Mandeep also gave right answer. Manideep, right? And Sharanya also right answer. Fine, bache. In this question, I just added both the solutions. I just mixed both the solution. Sometimes some variation also possible. Sometimes what they can do, they can add extra water also. They can add some extra water also, so be careful about that. In that case, V3 will be V1 plus V2 plus volume of water also added. That is also important, right? So I'm giving you one question on that basis. Okay, bacha. Let us see then. Here we have. Here I'm saying it is 0.25 molar solution. It's 400 ml. I'm saying it is HCl solution, imagine. Okay, or just we have glucose solution, you can say. And we are adding here 0.4 molar. And volume I'm saying it is 600 ml of glucose solution. The question is, we mixed, I'll say we mixed, right? We mixed both the solutions, both the solutions and diluted it by 500 ml of water, right? We added extra 500 ml of water in the above mixed part. The question is very simple. Find molarity of glucose in final solution. So in this, we can apply M1V1 plus M2V2 equals to M3V3, but be careful, the V3 is something different. V3 is not just V1 plus V2, it is V1 plus V2 plus V water, because they are doing dilution also here with it, right? Yes, beta, carefully give me answer. Both are glucose solutions, so I can apply the formula, no issue. Glucose. But be careful, we added extra amount of water. So please. Okay. Sharanya saying 0.24, 0.226, 0.226, 0.36. Let's check then. What's coming? Okay, so I can say here, I can apply M1 V1 plus M2 V2, and here we have M3 V3. But clearly V3 is something else this time. If I write here, V3 is V1 plus V2 plus volume of water added extra, right? So, but what is M1? M1 is 0.25. Volume is how much? 400 ml plus M2 beta. What is M2? It's 0.4 into 600 ml, and M3 I have to find, but M3 if you see carefully, it is 400 plus 600 plus 500, right? This way if you solve this one, I am finding M3. From here how much coming? From here how much coming? 100. 100 from here. From here how much coming? 240, right? So 100 plus 240, right? 340 coming, right? 340 and divide by, from here is coming 1500, right? So 340 divided by 1500, fine. Definitely we can cut it down. So 34 divided by 150 molar, you can find from here easily. 340 divided by 1500, fine. Calculation you can do a little bit, whatever coming. I think you are saying 0.26. Let me check. Yes, it will come definitely 0.22 will come. 4 will remain extra. 0.2 is coming, so it will give you extra 40. So 400 is coming. Yes. So 2 will come again. Then yes, 226 right answer. 226 is right answer. Very good. Most of it is right answer. Okay, fine. Clear, bache? Okay. So one more thing we have to understand here. Carefully try to understand. Look, I have a solution. I have a solution here. I have solution. This is I'm saying it is 0.2 molar NaCl solution. This is the next solution here, and I'm saying it is 0.5 molar NaCl solution. There are two solutions, and I am adding both of these beta. I am just mixing both of these. I am not adding extra water, nothing else. I am just adding both of these, right? Just adding both of these. So I want to ask you, what is the molarity here? Okay, so question is, I'm writing here a little bit. So first you write this part, then I will ask you question. Here carefully see, I am not giving the volume. I am not writing the volume here. You write this much part, then I will write the next half of question. Question is something else. This is a question of common sense, right? Not a numerical question of common sense. I'm asking you here. Okay. Okay, I'm writing here. Yes. We can save some time. Fine. The question is, what is the possible molarity of final solution formed by mixing given solution, right? We are mixing two solutions. I'm not adding any extra water. I'm just mixing both of them. The question is, what is the possible molarity? I'm giving you option. Here options are very much important to give. First I am saying 0.15 molar. Second I am saying 0.65 molar. Third I am saying 0.7 molar, right? And here I am saying the fourth part. The next part is fourth one. I am saying here imagine 0.38 molar. So which of these can be the possible answer for the given question? You cannot find the exact data. You can't find the exact data because I have not given you volumes. You can't apply M1 V1 plus M2 V2 because I have not given you V. So it's a question of common sense, not a question of like you will not solve it. You will just think about it. Think about it, beta. Think about it. Niranjan is saying right. Karthik also saying right. Be clear about it, beta. Whenever you mix the two solutions, you will see always the M3. Whenever you mix two solutions of same solute, definitely I'm talking about, M3 will always be in between beta what? M1 and M2. The final solution will have molarity in between the both solutions. If you mix two solutions of same substance, the final solution will have molarity that will be in between the two given solutions. It is how much? It is here 0.2 molar. It is how much here? 0.5 molar. So M3 will be definitely the M3, if I'm saying here, the M3 will be definitely more than 0.2 molar and less than what? 0.5 molar. It can never be more than this, can never be less than this, in between. So which option is in between both these values? Which option is in between both these values? Tell me. It is less than this one, it is more than this one, it is more than this one. Only this is the option which is in between both the values, that is 0.38. Exact value definitely we can't find because they have not given the volumes, but we know it very much that it will be in between. So whatever option is given in between both the values, it will be your answer. Depending on the volumes it will change, but the out of 4 options it will be in between both the values. If you mix two solutions of same solute, the molarity of final solution will be in between the two, more than the lower value and less than the higher value, right? Okay, bacha. Okay, so remaining type we will see in the next class. Tomorrow also, like we will cover the normality, equivalent weight topics, and we'll see some more questions, mixed questions from the PPT, right? Okay, bacha. I hope you enjoyed the session. Stay tuned. Bye. Thank you very much.